Hi, I'm Keegan, and I'm with the Econ Tutoring Center. And today I'm going to be talking about the product rule for derivatives, which is very handy. So let's just go ahead and jump right into it. I guess, first of all, it could be that your professor uses different notation than what you'll see used in this video. Most likely not, but in any case, it's a good idea to know all the notation that might be used for a derivative. You should already know about the power rule and why you would use a derivative and what a derivative is. So if you don't, maybe it's a good idea to go back and review those videos. So let's get started with the product rule. So suppose that our function of x, we can go ahead and call it y, can be represented as a composite of two functions, or the multiplication, the product of two functions, using the product rule, of course, right? Then we might say that y equals f of x equals g of x times h of x. Okay? So let's go ahead and talk about examples of functions that might look like that. Say we had x, so say f of x equals x ln x, or x times natural log of x. It's really easy to see this is kind of one function of x multiplied by another function of x. So here g of x equals x, and h of x equals natural log of x. Right? So let's learn the rule. So the rule is, if you have a function that's of this form, then the derivative of that function with respect to x, which is the effect of a change in x on the whole function, is equal to g prime of x times h of x plus g of x times h prime of x. Okay? So if we go ahead and return to our previous example, then we can say that if y equals x ln x, then the derivative of y with respect to x equals, we'll go ahead and do, so this is g of x is x, so g prime of x is the derivative of x, which is x to the 1. Use the power rule, we find that the derivative of x is 1. Okay, so equals 1 times h of x. H of x is natural log of x in this case. So equals 1 times the natural log of x plus g of x times h prime of x. So once again, g of x is x, so x times h prime of x. And since h of x is natural log of x, we go ahead and use the logarithm rule to say 1 over x. Okay? And the result, therefore, is natural log of x plus x over x, which is 1. So this ln x plus 1 is the derivative of y equals x ln x with respect to x. So this is something that's really good to learn. Let's go ahead and use a couple more examples. Let's go ahead and use a polynomial. So let's see how that looks. So suppose we have y equals, say, x squared times 3x cubed. Okay, Now we could multiply this out and just then use the power rule, but we can also use the product rule for each of these individually. So the dy over dx here is the derivative of this first function times the second function. Okay. So derivative of x squared using the power rule is 2x. And the other second function, of course, is still 3x cubed. And then we add to that g of x times h prime of x. So the first function times the derivative of the second function, which is x squared, which is g of x, times h prime of x. So we take the derivative of 3x cubed, which happens to be 9x squared. And that's it of this function. Okay? And we can actually combine our terms if we want to simplify. So let's go ahead and do that. That's this is 6x to the fourth plus 9x to the fourth equals 15x to the fourth. And we could also see that if we went ahead and used the power rule, I'll leave that as an exercise for you, but if you multiply this out and then take the derivative of that, you're going to end up with the same result. Suppose y equals f of x equals e to the x plus 5 times 3x squared plus 2. Then, once again, this is our g of x, this is our h of x, and we go ahead and say dy over dx equals the derivative of this first one, which is e to the x, using the exponential rule. And we multiply that by h of x, which is 3x squared plus 2. 3x squared plus 2. And so that part is done. Then we do g of x times h prime of x. So e to the x plus 5. X plus 5. And multiply it by h prime of x. So that's the derivative of this. We can go ahead and use the power rule to find that derivative. We end up with 6x. And once again, we can simplify that if we wanted to. I don't really feel the need, but hopefully that should tell you how you can solve for the derivative when you have a function that's a product of two other functions of x. If you have any further questions, you can go ahead and leave a comment on the video, or you can also visit us in the tutoring center or ask your professor.